Hey everybody, and thanks for checking out the Storage Review Podcast. I'm Brian Beeler. Last week, we had the opportunity to go to an actual trade show. Yeah, a real-life trade show in St. Louis. It was Supercompute 21. A great experience. Of course, the attendance was a little bit lighter, a couple thousand people versus 12, 13,000. The exhibits were a little more Spartan than usual, but there was a certain energy there that was really cool. The guys and gals that were there wanted to be there. They were excited to be there. And so even though the audience was smaller, it was really energetic. It was excited. It was enthusiastic. I mean, a lot of adjectives to describe the same thing. But the point being is that there were a lot of people that wanted to be there to see what was going on in the HPC supercompute world and a little bit of enterprisey stuff too. All sorts of cool exhibits there. One of the places we spent a lot of time was at the Supermicro booth, and a couple reasons for that. One, it was one of the biggest booths on the floor, maybe the biggest, with a lot of people, a lot of new stuff that they were showing off, a lot of blade chassis and things that we've seen and reviewed recently. So it was great to be able to connect with that team. But it was just another opportunity to get that human contact that just doesn't work so well over Zoom. I mean, if anything, we're seeing the decline of attendance on these online events the second year around. So it was great to see SC go off in person and get to spend a lot of time with the Supermicro team there, as I indicated. One of those great conversations I had was with Vic Maliala, who was able to walk us through the new equipment, walk us through some of the other stuff that was released in the last few months, and really get a whole demo of all of the cool stuff that was going on there. So let me bring in my friend Vic. Vic, how are you?
Hey, thanks for having me. I'm doing fantastic.
Well, you made it back to the office, I can see, with a giant badge over your head.
Yeah, we are so fortunate that, thanks to all the vaccination that's available to us, we could, travel freely, at least in the U.S., and be safe.
Yeah, well, you took the traditional route with an airplane. I drove over from Cincinnati, which was an adventure. I'm not a long road trip guy, so that car time was unusual for me.
At least the traffic should be better. I mean, with all the reduction in people on the road, but definitely it's a long ride, I'm sure.
Yeah, the traffic is better, but for whatever reason, the two-lane roads between here and anywhere in America, one lane is always closed and under construction, so I don't think it makes much difference. But, in the run-up there, I said how excited I think the vibe was there and the people were. I mean, you guys had a jammin' booth the whole time from what I could tell. I mean, you had some people there, and I think you said as soon as people found out you were going in person, you had some more signups. People were eager to get out of the office. Like, what was your take on the vibe or the feeling of the show floor there?
Yeah, truth to be told, in the very beginning, we were a bit skeptical whether the event would even happen in person, because there are so many events that we scheduled for, planned, and got canceled. But supercomputing is one of those events that everyone gets quite excited about, mainly because look at the kind of things that we are facing, whether it's related to COVID research, whether it's related to, any kind of acceleration of innovation, and supercomputing in the smack center of it. So initially, people were not sure whether they want to go or not. This was like I'm talking about 3-4 months ago when they were planning for the event. But as things started getting better and as we started reaching out to customers that we are going to be present both in person as well as online, we actually started seeing customers putting requests to come and see us at the event. So it kind of built into the momentum, and it did not let us down. I mean, as you can imagine, the number of people in the show is less, but the quality of staff, I mean, people who need to be there, who wanted to be there, who ended up getting permission, travel there, they were there, right? And it was exciting to meet those people. I mean, nearly after 2 years of not seeing the customers. And for them, being able to actually face somebody in person and actually see the products in person and touch and feel, I think it was good for both sides, I would say.
Yeah, I totally agree. And it's funny because we came at it from two different angles. I mean, you were exhibiting, and of course, I'm sure you got a chance to detach and walk around a little bit. But, I spent most of
Mhm.
my time floating around the booths and seeing things. And, I think another opportunity that came up for me was the ability to interact with a lot of companies that maybe I wouldn't have otherwise. Not that I don't want to, but just like if the show floor is open for 7 hours or whatever the number is, there's only so much time you have to physically go around and see the demos and have those conversations. So I think it was a net positive for a lot of the smaller companies that maybe wouldn't have had as many conversations otherwise. So there was some silver lining on the cloud, I would say.
Absolutely. I think as long as we plan our meetings well and we go and spend some time with these customers. I mean, to your point, even I had a little bit of break in between to go and see, what the other ecosystem partners are doing. I mean, we have our products that are also either used as they are or rebranded and put in their booths of several partners. But at the
Hmm.
same time, when you talk about the ecosystem, it's not just the server and storage hardware, but what people are doing with respect to cooling, with respect to interconnect, with respect to next generation technologies that we should be watching out, and how we make it easy to deploy, easy to manage. These are the things we read a lot about in articles, but and having an opportunity to go talk to those people and see where they are headed and what they are thinking, that I think is invaluable.
Yeah, I totally agree with you, and that's one of the reasons why I like the show so much. Is not so much for the supercomputers, which is sort of ironic because that's the core of the show. But I think like with OCP is another one. Supercompute is another good example of places where leading edge technology is occurring, and whether it's in AI ML or if it's in open compute standards, if it's whatever it is, the leading hyperscalers and thought leaders in intelligence are doing these types of things with these high end pieces of equipment. But that technology will come to the enterprise in a more consumable way, and we can talk through some of that. But all the work that's happening with GPUs, with interconnect, as you said, with storage, even there were a couple storage guys there showing off stuff like Samsung had a CXL demo that was pretty sweet. You talked about some of your partners. Weka was there, showing off, some of their integration with your servers as well. I mean, there's so much going on there that I think is going to be relevant to the mainstream enterprise and even SMBs in the next year or two. That this is sort of that window to peek through and see what's coming, what's already being done, and then what's going to get more productized and consumable, down the road.
Mhm. Yeah, I mean, I think you mentioned one thing that's extremely important here is that supercomputing, as it typically goes in national labs and research centers, that is given, right? But
Hmm.
the amount of supercomputing that's being adopted in enterprise customers is a lot more than ever before. And the trend definitely seems to be pointing in the direction where the adoption is going to be a lot more going forward also. So uh, effectively, what it means is that uh, we need to make these products easily to be deployed and managed because they do not necessarily have the same type of technologists and engineering resources as typical research institutes do.
Hmm.
So the adoption is increasing, and the need for easier deployment of these products also is increasing.
Well, let's talk about some of the stuff that you were showing. I mean, that's where you and I spent some time together. I know you have the universal GPU. I know you've got liquid cooling. I'm going to tell you my favorite thing that I saw at your booth. Are you ready for this?
Hmm.
The th- the 3.5 inch hard drive caddy.
You know, I was actually challenging the team when they were having all the demo list finalized because you know that we have really a lot of products. I mean, you're talking about a wide gamut of products, and obviously we cannot show everything at the event because of as big as the booth was. We
Sure.
just can't put all, right? So we ended up picking and choosing few of these platforms, and the team came up with like, hey, can we actually showcase this product? And I was like, why? I mean, it's a supercomputing event and all that. But in the end, we were so glad we took it because the amount of interest that we had from the customers was insane. I mean, I was actually, to your point, I was expecting like, people are jumping all over these different GPU and accelerated platforms, which they did. But
Sure.
there was significant interest on this high capacity top loading storage. And and then as I mean, honestly speaking, as we started looking into why we need to showcase, we looked at what are the differences in the platform from the previous generation, and that actually was, reason enough for us to bring it and at least show to the people that that are looking for a high capacity storage with various kickers, right? I mean, you're talking about high performance, high availability, and ability to scale easily and all that stuff.
Yeah.
Yeah,
Well,
I
I
mean,
mean, I can't tell you how many screws Kevin has lost under the racks in our lab over the years. But if we were to magically be able to pick up the racks and move them, there must be 9,000 drive caddy screws under there. So when you or one of your guys popped out that 20 terabyte drive and was like, hey, check out the new drive caddy that basically it wraps more or less around the 3.5-inch hard drive and then just chunks it into that top load system in 2.5 seconds. I know it's such a nerdy thing, but when you interact with hardware a lot, those little time saving things and life simplification things go a long way. So I hope you put that caddy in everything. It's fantastic.
So the feedback was that as people are deploying these at scale, the serviceability is a big pain, right? When something needs to be serviced, the downtime or the time it takes time is money, right? So that feedback we have taken quite seriously. And we looked at a few different things. If you take a look at that caddy, one thing that we have done is, literally without any screws, you can pop it up and put it back on within no time, like a couple of seconds. But we have also made it in a way where if people wanted to use a 3.5-inch drive, or if they want to use 2.5-inch drive, depending on what they want to do, we incorporated that into the drive cage. So depending on what people are looking at, they can have a mix and match of those, easy to be popped in and out. And if you remember, the way we have even developed this platform is one do not have to reach to the back side of the chassis ever, right? All the servicing or serviceability aspect of it is done from the front, and all the cabling is built into the enclosure. So you don't have to have a separate cable management arm in the back of the system, which typically ends up, complicated. And then we were able to, the one that we actually showcased was a 60 bay. So where we could pull like 30 bay first, and then we have additional latch we need to release to bring the next 60. So I think
Right.
the improvements done through in and throughout to make it, number one, easy to service it, and the amount of time it takes to manage any piece of it is minimized as well.
Yeah, the sliding latch too is a good point. That when you're dealing with these large, heavy systems, that even just manipulating the drawers can be a challenge. So it's when you're sliding it back in, it locks in increments. So that if you're just servicing, a drive in that front row, for instance, it's easy, and you don't have to, have the whole thing out, or don't have to worry about it quite so much, and easier one-person operation too, right?
Exactly. Yeah.
Hey, so speaking of OCP, Seagate was showing off NVMe hard drives 2 weeks ago at that event, and SC seems like a good target, and a device like your high capacity systems where you might still want to have some NVMe flash in there to accelerate those big bulky data stores. I didn't even ask you last week, but do you follow that much? What do you think about NVMe hard drives?
I know. Actually, I love it. The the ultimate use case need to be figured out, right? If you take a look at uh, in a typical storage scenario, you have high performance flash and then high capacity storage, and you do tiering and all that, right? And within a given drive, there's always a bit of cache. I mean, you're talking about 16, 32, whatever megs of cache that's there. But as you add some NVMe flash, to this hard disk drive, you are able to kind of stretch the performance limits of the traditional spindle, because you're talking about within a drive, you're able to cache some of it, and you're able to write in the back end to the spindle. So you can actually take the performance of the storage system to the next level. So what does it mean? As you deploy it in high capacity storage systems today, the systems are designed based on the amount of throughput that we can get from a given drive, and we kind of multiply by the number of drives that we are putting in enclosure, and based on that we add certain number of expanders or certain number of storage controllers to optimize for both capacity and cost and performance for all three of them. But now the equation changes a little bit as you bring this additional performance in a given drive. Then we need to look at how the platforms should be designed to take advantage of it. I mean, as such, just by dropping the drives in a traditional system would just do fine, but you're not necessarily capitalizing on the performance benefits of it. So it does give us an idea to, or a challenge to resolve it. I mean, what kind of, let's say, number of drives that we can support in a given system, how we do the performance optimization, especially with PCIe Gen 5 going to be in the platforms in a very short period of time. Of course, the storage controllers and other things need to evolve with it. But overall ecosystem, definitely we are moving towards being able to provide a lot more bandwidth, from a given system. So if you are able to bring that performance per drive up, we can create more innovative platforms to bring the best from what Seagate can offer at this time.
Yeah, and hopefully, one of the other goals is to give you a more simple server design too, so that you're not having to engineer for SATA, SAS, and NVMe in the same system. If you can just go flat NVMe, then from an engineering standpoint, that maybe simplifies it a little bit.
Right. So today, there's a significant portion of customer base has shifted to NVMe, but there's quite a bit of applications that are typically SATA SAS based. What we have done at the platform level for us is to create the backplanes where you can have NVMe or SATA SAS drives to be connected. At least from the platform point of view, we don't have to design three different platforms. We can have like one platform with a simple backplane where the cabling can be handled in the back end to support these drives. But to your point, if the interface point of it can be standardized, definitely it will help. However, there is still a significant percentage of customers that are using traditional RAID functionality,
sure.
Which is a bit tricky when it comes to NVMe drives because of direct connect to the processor. And even if you take tri-mode cards and whatnot, you have to play with those PCI lanes properly to get the right performance.
Absolutely. Yeah, check out the, part of what was going on at that show floor, there were all sorts of computational devices out there, computational storage devices. Plyops was on the show floor showing off their edge card accelerator, which actually uses like a little DRAM module on it, and it's got super caps, and that thing's pretty cool when it comes to accelerating. In their case, the demo they were showing was Intel's QLC drives, so that's a pretty neat use case of an SSD that's essentially a hard drive replacement being accelerated by another piece of technology. The other one, they weren't there, but is Grade that we've worked with, which is a GPU-based accelerator for NVMe. So you can drop this GPU in the Grade software, and it can aggregate all of the NVMe drives just on the lanes without having to be physically connected in a way that we think of sort of legacy RAID cards, right? But yeah, there's a number of guys out there going after these types of problems of once we go to all NVMe, especially flash, how do we aggregate this stuff in a way that's non-overhead oriented or limits the overhead and really lets the drives go sing? Because that's been the problem with the NVMe RAID cards for years, is that you couldn't put it more than a couple drives on without saturating.
Yeah, and interesting that you brought in PlyOps as an example, and they were our neighbor at the show floor. And if you have seen the product that they were showcasing in their booth, it was actually based on a Supermicro EPIC-based platform. It's a single socket WIO with 10 NVMe drives. And look at how the industry converges, right? And we are using the Intel QLC drives in an AMD EPIC-based system with a PlyOps accelerator. Mainly, if you think about the advantage that they were trying to bring, at least one of the advantages that I saw obvious was you don't necessarily need to go for TLC or even a higher endurance drives in order for you to use it in several enterprise applications, because of the way PlyOps is intervening in between on how the data to be managed. So they're extending the life of a QLC drive, and I think it's exciting because we are bringing technology from different partners. They are competition at some time, they are partners at some other time, but ultimately Intel, AMD, Supermicro, PlyOps, and all these things coming together to provide a solution to the customers. So that's a very good part about that particular demo they are showing there.
Oh, yeah, absolutely. I mean, those 5316s from Intel, we've got a couple of them that are the 30 terabyte class. They're really, really cool, and 30 terabytes in a little thing that's not, it's expensive, but relatively speaking, is not as expensive as flash has been historically, is really neat. But you have to be really careful with QLC if that's your primary data tier. And some of these accelerator cards and computational storage devices are just neat in that they start to give you the ability to take full advantage of the flash and mitigate the performance delta there when it comes to writing to the drives. Read, they're still super quick. That's never been QLC's problem. It's just that it wants to be written to in a very gentle way, and so these cards can kind of bridge that gap, right?
Correct.
Yeah. So that was a long riff on hard drive caddies. So that was good. Two other big themes going on that I noticed. Liquid cooling was at least a quarter of the show floor. I mean, you guys were showing blades with liquid cooling. We actually got you to one of your guys found a drill in the back and took the lid off, which was cool, so we could see that. We put those up on social and got some good engagement there. But all over, there were connectors, there were pumps, there were fluid designers, there were all sorts of things going on. So, I mean, obviously you've got a perspective on it since Supermicro's investing in liquid cooling solutions for your traditional servers. And maybe very soon, all servers will have to be liquid cooled, or all multi-CPU, multi-GPU servers, because there's just going to be so much energy there. But what's your take on the state of liquid cooling? Because this is very much a central theme in the HPC world.
Yeah, so we've been investing our time and resource for the last, I would say, 5 or 6 years. In fact, I think in 2013, 2014 CeBIT, if you still remember that event in Europe, that was the time we were actually showcasing some of our liquid cooling systems. But ultimately it boils down to the customer requirements, right? I mean, liquid cooling was great. It actually can improve the efficiencies quite a bit, but the cost to take it to deployment and the pain in terms of managing the post-installation, those were the primary concerns for customers to adopt it. And the performance improvements that are coming from both CPU and GPU and well, even the accelerators of different type, that kind of mandates the need for an alternative cooling to forced air cooling. I mean, you have seen the platforms on the floor. We have many of them that are for you when it comes to these accelerators, mainly because we needed to have these big heat sinks, so people do not have to change the way they use the systems in their data center, and they can still operate. But as you start looking at bigger clusters, there is a lot of need for higher density and need to reduce the footprint. So as long as there is enough power, we can pack this, but then the cooling becomes a nightmare. So we started, looking at more than one alternatives for liquid cooling. So obviously, the direct-to-chip liquid cooling is one of the things that is getting most traction, and mainly because of you don't necessarily have like too chilled water. I mean, you need to have definitely water to the data center in order for us to use it. But the best part about this is that's the least intrusive when it comes to managing the system. It fits into the standard rack, and as long as the rest of the stuff is properly plumbing is done, then you can actually use it. And we have deployed several HPC clusters, and then we kind of got the best practices figured out in terms of how to manage these things. You don't want anything to leak, you don't want anything to blow up. How do you do all those things, right? But that's just one part of it. And then when I started talking to customers in Europe and some of the telco customers and some of the customers who are using at edge data centers, suddenly they seem to be a lot more open to adopting even immersion cooling. Which was quite kind of surprising, mainly because I think these guys were used to managing, let's say liquid cooling of some sort, like 20, 30 years ago, and it's coming back right now for them to use it in that way. And again, that kind of takes it into a further segue, let's say it fragments the market in a way, which liquid you want to use, whether you want to use the standard systems and just dunk them in the liquid, or you want to have a bit of more optimization done on that, so which increases the density and reduces the inefficiencies. But then there's a cost associated with it because you're further customizing and you're pigeonholing yourself into that part. From Supermicro's point of view, and coming back to that point, is that we started talking to different customers, we started collecting their feedback, and we have solutions that are being prepared and also being worked on for the future deployments with direct liquid cooling as well as immersion cooling. It is going to be adopted a lot more than before, but I do feel that there is still a big portion of the market that cannot just take liquid cooling because of the way the data centers are designed. So that's the reason, even if you take a look at something like our universal GPU platform, we are designing it in both 4U and 5U. The 5U is basically to give additional cooling capability so people can still use it in a traditional sense. So while the direction is absolutely clear, there is going to be, let's say, a mix of, and there's going to be a ramp up that is needed. And I think it will happen in the next year or two as people try to come into agreement with what need to be done and the systems to be deployed in a more efficient way. And cost, again, cost is absolutely going to be a criteria that people will look into it. I have a feeling that will come down, and there are going to be more innovation on that front that will make it easy to be deployed in a traditional data center.
Yeah, I mean, that's part of the trick even that we think about here is we only have 8 racks, but okay, so what, it may not matter because not next year's servers, but what, 23, 24, I mean, we may get to the point where liquid cooling is fundamental to more servers than it's not, okay, or at least high performance servers. So it's a question too of how are enterprises or small businesses going to adjust there? Is it we all tap into the liquid supplies that are, every office has water. You have to, right? But how do you how do you make that work, right? And how do you start to tell that story? So I think that's an interesting challenge. Once you're there, obviously hooking into the back of your Superblade chassis that have all the cooling elements in there, that's easy. That's easy stuff. Do you think there's it seems like there may be a bridge though in between where, like in the PC space, where CPU cooling and GPU cooling on internal loops has been a thing for many, many years, that cooling CPUs and add-in cards or add-in devices, GPUs, maybe in the universal GPU example, could that be done with internal cooling systems that are liquid cooled but not full water or hydro hookup?
Yeah. In a workstation front, as you said, it's very common, right? People actually have a heat dissipation within the same enclosure. We also have something called like a liquid to air or L2A type of solutions where you don't necessarily have anything externally connected, but you have several cooling loops that are connected to systems within a rack, and at the top of the rack is where we have like this massive heat distribution unit. All these things are connected too. That way, you don't necessarily have an external cooling or liquid coming into the system. So yes, there are alternatives, and it also depends on the size of the cluster, as well as the amount of space that they have within a system, and how much cooling that need to be provided. Because obviously, when you have a lot of heat generated, you need to have to cool it, within that. To your point, we have seen some of these solutions offered by, several companies that are displaying their products at supercomputing, where literally a full rack with a, big, heat distribution unit, so that way they can take on anything. So, as I said, there are many solutions that are going to hit the market very soon. And depending on what problem we are trying to solve, like because you're talking about a density, the heat dissipation, the cost, the ease of management, all these things need to kind of align for you to pick the right platform. So it is going to be a hybrid. It's definitely the right direction, and it will happen. Again, based on these factors.
Yeah, I saw some while I was there, and I've seen them before, like the radiator rack door, right? And it's got some extra fans in it, but a lot of heat dissipation material, and whether it's liquid into the door or something else to pass that energy from the servers to the door and let the door be just a giant heat sink is pretty cool. You think about a little M.2 SSD with a heat sink on top. It's the same idea with fans and metal to get rid of that heat. But yeah, there may be several interim solutions to help organizations bridge that gap without having to go full liquid cooled, because that probably won't happen in the enterprise right away either.
Right. I did see the rear door heat exchanger solutions that customers asked Supermicro to deploy. We have done that. And to your point, that is the least intrusive, right? As long as you have a chilled water there and it actually taking the heat away from that, you do have, the standard systems that you can just be plugged in, and you don't need to worry about, making any changes. But the next best is the direct-to-chip liquid cooling, like you have seen with our blades, the GPU products, the Big Twin, several platforms from Supermicro, where people are okay to adopt it with direct-to-chip liquid cooling. And then taking it a step further is, we have several partners on the liquid cooling side of it for immersion. That is also something we are providing as an option. Most importantly, what I feel is that it's impossible for Supermicro to address all kind of customer requirements in different geos. And that's where our partner network is coming into picture. We have several partners that are taking system integrator partners that are taking our systems and working with some liquid cooling or alternate cooling solution providers that are regionally available and vetted for or preferred by an end user, and they are bridging the gap. So it's actually a good and bad thing, because when everything goes well, it's fantastic. When things go wrong, then actually Supermicro's name is also going to be at risk. But I think
I can't believe what I think I heard you say is that Supermicro needs more products. You guys have 8 billion SKUs.
But I think ultimately it's a customer driven. I mean, we do have building blocks, and that's the direction that we are leading with, even in developing our universal GPU platform. But ultimately, if you are talking about customization for a given application, for a given end user, no matter however many products that you have, there is always something better that we can do. And some we do it directly, and some we do with our partners.
All right. Well, let's talk about the GPU platform for a little bit, because that was, I guess, your big news item from the event. So that was an emphatic launch from you guys. It seemed, now you wouldn't let me take the lid off the thing, which I'm still a little upset about, but it seems to be that there's a lot of momentum around getting the GPUs or accelerators. Intel's obviously working on a product there that uses this same slot-ish, getting those on the board versus dropping them in as add-in cards. Talk about that sort of fundamental difference, so that we can really understand then what you guys are doing with Universal GPU Server.
That is a loaded question, and then I think we can we can answer it in many ways.
All right, well, break it down a little bit. How is the approach different than the traditional add-in card approach?
Okay, so first things first. So basically, it started off like, you have a processor and you throw some GPU or accelerator into your platform in a very simplistic terms, right? And then came a need for multiple accelerators to be populated in a given system. And then people started talking about the data is not fitting in a single GPU, so it need to be communicating with the GPUs next to it. So which basically means that there's a latency associated with it. Then we started talking about peer-to-peer communication. So then we started talking about different topologies that come with it. So everything falling under a single root complex or multiple root complexes. So depending on that, one need to make a determination ahead of time as to what the application that they will be running and how it will be used. And one of the things that has been done is initially by NVIDIA in terms of SXM or AMD point of view, they have their own link associated with it, like NVLink versus something else. The reason is basically they are bypassing the traffic going through the processor and communicating between the GPUs, which is great. And the latency to further improve, that's when the whole SXM modules that came into picture, where you could be connecting these multiple units on a given board through its proprietary interconnect, which is high throughput and low latency interconnect. That way, if one has to move the traffic between the processor and the GPU, that is not impacted. But if the data traffic were to go sideways, east-west, then you are able to handle that as well. If you were to take it across multiple systems, now you need to have some kind of a switching and some kind of a connectivity that goes between them. So that's the kind of a background on that. So when we started looking at what situation today is, there is, of course, obviously NVIDIA, the industry leader, is there, but there are several other GPU and accelerator companies that are there. Like when you're talking about Intel, you talked about AMD,
with
Habana,
more coming, right? Yeah.
Many, right? And some of them are already in the market. Some of them are in development. So in parallel, there is another effort on standardizing it, because if everybody has to develop a brand new architecture for that, it's not going to fly. So that's where the OAM, or the Open Accelerator module, that is defined. I think it kind of started with Facebook and few companies that kind of driven in the direction. So we are able to standardize the platforms based on that. So then the processor point of view, there are a lot of things. I mean, we are talking about Intel, talking about AMD, and we're talking about maybe even ARM in future. So on the processor side, we have multiple processor architecture. And in terms of the accelerators, we have different accelerators based on the PCIe form factor, based on the SXM form factor, based on the ones that are OAM form factor. So you mentioned that Supermicro has many platforms. Just imagine how many more the platforms going to be if I were to have to make a platform one for each. So,
Yeah.
and then we started off this idea of universal GPU 2-3 years ago, and it took some time for us to materialize that. We needed to have a platform that hopefully is able to accommodate multiple CPU complexes and multiple GPU or accelerated complexes, and be able to connect them in a given system in different topologies. If you're taking the PCIe form factor in a single root complex or multiple root complexes, and how you want to have the local storage mapped to a specific accelerator, to specific processor core, to a given interconnect in the back. So we thought about it and created a platform that we believe is a universal GPU platform, or at least going to transform into one, to accommodate all these different things. So I think at a high level, I think that is what it is. And the first product in that in that architecture that we released was actually based on the third generation EPYC as a processor, and the GPU point of view, it is the AMD MI200 or MI250 OAM form factor GPUs. So it's basically 4 OAM modules with 8 GPUs in them, connected, as I said, using the OAM with its own dedicated storage, dedicated, let's say, network card to bring the best performance out of it.
Yeah, so you talked a little bit about the reasons why you need that, the benefits of proximity of the GPUs, of the GPU RAM more than anything else, right? And the efficiency of the way you've laid out storage and networking to kind of go one to one to one, on this this sort of modality. What? How would this compare then to a traditional add-in card architecture in terms of, you probably have a density advantage this way too, because you still have all your PCIe on the back for network or whatever else you want, right?
Various things, right? I think, definitely that's one of the advantages, but even more so, if you take a look at the standard PCIe form factor double width card, it's about 300 watts. And mind you, now we are talking about accelerators. People are bringing it to 600, 700, 800 watts per. And it's impossible to support that in a traditional, double width PCIe slot. Maybe we can, make it even bigger and have extra power, but it just becomes too bulky. Versus having this OAM form factor, or from NVIDIA point of view, it's the their own mezzanine card form factor, right? Mm-hmm. These are the ones that can accommodate a higher wattage, and much of the interconnect between that is in the board as we design the board for that. Makes it easy for us to cool it by liquid cooling, or putting a bigger heatsink in a bigger enclosure to do that. So I think there is the disadvantage of this kind of a platform is that if it is a 4 GPU system, then you are installing 4 GPUs. You cannot say like, I'm going to start with one and then build on that. Right. It doesn't work that way. Versus the PCIe form factor, which is the reason why a lot of people prefer, is they can go with 1 and go all the way to 10, for example. And other thing here is if one wants to play with the different accelerators to see how it works, and not all of the slots could be used for accelerators. People use some for networking, some for like a video processing, some for data processing, different type of cards, different type of connectors. So all these things can be easily supported in the PCIe form factor boards. So both of them will coexist, and depending on, again, what problem the customer is trying to solve, one would pick that.
Yeah, so once you understand your workload and you really know what you want, and you want to standardize on some blocks, building blocks for that, then maybe the universal GPU system is a better fit at that point when you're past some of the need to be flexible and sort of learn what your options are, right?
Absolutely. And then one standardization in a platform like that, it makes it easy for the rack layout. It makes it easy for the system management tools and anything that you use, because everything, if it is based on the standard industry standard architecture and the way we manage the systems, the way we operate them, it becomes much easier for them to plan their infrastructure as
Well,
opposed to
yeah. So speaking of infrastructure, then what's your take on some of the momentum that's behind either disaggregated or composable, depending on how you go at it? So rather than try to squish all this stuff together in one server, why don't we have a storage server, a GPU server, compute server, and pull those components together virtually to make my AI server a thing? DPUs, that was another big trend there. Fungible was there showing off their DPUs. Liquid was at the show talking composability. Obviously that's their thing. Nvidia has been talking DPU for almost a year now. Pretty heavy. What do you think about some of these emerging alternate architecture concepts?
These are great, right? I mean, if you really think about it, ultimate goal is to utilize every piece of the given system more efficiently. And I know there are ways. One, if you know exactly what you're trying to do, and if it can be provided in a given enclosure and easy to scale, that is one approach. Other one is basically, hey, you know what? I am going to use multiple workloads, and I do not necessarily know ahead of time if it's going to be compute intensive, if it's going to be storage intensive, whether it requires a lot of accelerated compute needed in that or not. Then composable infrastructure is going to help quite a bit on that. And whether the composability exists within a given enclosure and scales, or whether it is going to be totally disaggregated to manage in a different way. There are different ways to slice and dice. So that's the reason. I mean, we work very closely with Liquid, right? I mean, the solution that they are bringing is very valuable for a lot of verticals, and that's a good value. And at the same time, depending again on the customers, what they're trying to solve, if the solution can be rightly fit into theirs, then there's no need for that, right? So both of them is going to coexist, but definitely as the deployments start getting bigger and more heterogeneous workloads are going to be supported in these platforms, having an ability to provision the resources is much easier, whether it is much more important, whether it is going to happen within a system or within a rack or a data center. And we know that this actually exists. Like we have storage that is already external, and we have compute portion and GPU either connected externally or have everything in the same system. There are going to be some caveats, right? You're talking about the overhead associated with it and the licensing cost associated with it. Like with anything else, we need to see what problem we are trying to solve and pick the right solution for that. And we will continue to work with our partners to bring that value to the customers.
Was there anyone on the show floor that you're not a partner with? Every time I say something, oh yeah, they're a great partner. We're doing all sorts of fun stuff with everybody.
I mean, because it's needed, right? I mean, we kind of built our entire product line based building block approach, and our customers can take advantage of it with our partners, especially whether it's going to be an OEM partner or whether it's a software only partner. As I was mentioning, on day one or day zero, on Sunday when we got all these products at the show floor, and I saw like, oh, this product is going to Panasas, this is going to Weka, this is going to Plyops, this is going to Boston, whatever. I mean, I started seeing like, hey, do we have enough products to showcase in our own booth with all these things going elsewhere? But the reality of the matter is, and these partners together, as we work with them, we are able to bring the right solutions to the customers. Without that, hardware is hardware, right? What can we do with it? So I think the hardware point of view, what we are able to do, how we are able to make it easy to be deployed, easy to be managed, easy to be provisioned, and again, bring the highest performance and different form factors for the customers to choose from. And to your point, different liquid cooling or forced air cooling being supported in that. And as the next generation, you mentioned about Samsung showcasing, CXL in their booth. But if you have seen in the same booth, there is a Supermicro system right underneath that is a client that being used. So CXL is going to be absolutely important, and the first generation is going to have its own limitations. But as we start looking at the next generation CXL, where we're talking about cache coherency and other factors being built in. Now you talked about composability. That is going to take it to the next level. So we can have memory outside. You can have other accelerators. I mean, future is so bright, and supercomputing in that aspect is the one that makes us so excited, because we can go and see all these technologies, talk to these customers, partners, and all the scientists. I mean, it's always good to be in the company of smart people.
Well, yeah, I mean, if you want to feel dumb, supercompute's a great place to be, because these guys, and
I don't mind being one. Yeah.
Oh my gosh, they're solving the world's problems, and I'm just some dude from Cincinnati taking pictures. We did talk about CXL a little bit, but at the same time that Supercompute was going on, Samsung held a tech day, and I'm sure there was a Supermicro session at that too, right? But they showed off a number of things. We talked a little bit about SATA SAS. I mean, they're still on the SAS SSD bandwagon, the 24 gig SAS. I mean, looks like it might be interesting. But one of the things that was pretty cool was the 128 terabyte E1L long ruler that we'll see if that really gets into production. But that was pretty slick. You had a ruler server on the show floor at SC. What's your sense of what's going on there?
So that we were the first to bring this ruler platform, and we worked very closely with Intel at that time to bring that platform, because the idea was to get a petabyte of storage in a 1U. And, with 32 terabyte drives, with 32 of them, we were able to, get to that terabyte. And two things. Number one was, okay, you have this much storage in a very small form factor. Then what is the blast radius? How do you manage this? That was one of the concerns that people had. And second thing is, with a single supplier, if they were to have this, then their customers are at a risk of being, stuck with single vendor. I'm talking about Intel being the only one. But Intel was amazing in terms of driving the standards, and the E1L and E1S are the both standards. They worked with the industry leaders to define that. What we have seen is multiple drive vendors. I mean, talking about 3 or 4 of them. They are able to bring the E1S, which is a lot of interest is coming from the customers to use that, because this brings this eliminates some of the design challenges. If you take away the traditional backplane where these U.2 drives are connected, there's always these airflow restrictions, versus if you were to just find a way to connect it and streamline the airflow, you can get a lot more density. And given that both Intel and AMD is bringing a lot of PCIe lanes into the platforms, we are able to get the performance also as a part of it. Now, going back to E1L, what I have seen here is that people are figuring out ways to use high-capacity storage within the systems. And earlier, what happened is, if you were to use the two generations ago or 1 generation ago, it was PCIe Gen 3 drive. And PCIe Gen 3 drive, it's a by 4 connectivity. You have limited data that you can pull out from that. But now we are talking about PCIe Gen 5 and 4, and depending on the platform, you can even go to by 8 and all that. So you can get a lot more throughput from a given device. So what will happen is, whether it's a capacity play or whether it's a performance play, or whether it's a scale out in a hyperscale level deployment, these kind of things are going to be adopted. So obviously, not everyone is going to take like a 128 terabyte type of a drive. It's number one, it's going to be too expensive. and
Right.
two, they don't have necessarily the need to do that, and the amount of time it takes to rebuild, if, in case of a drive failure, that is a lot, right? But a balanced platform is what would be, people would be preferring, and even S is definitely going to take that spot, and even L, when people are using it, in a high capacity or high performance storage need, where they are depending a lot on the software level redundancy. I mean, erasure coding and few other things that sit on top of it, where a single or multiple drive failure is not going to hit them too much. So
Yeah.
it's definitely exciting to see the 128 terabytes. I would like to see it in person, to see how the drive looks and feels.
I think there's one. I think one. I think it exists in quantity one right now. Yeah, it's compelling. We've got some long and short rulers in from Hynix right now, and looking at those and what you can do with them and the flexibility. The hyperscalers, I think, for sure have done well to push that 15 mil standardization. And even though 15 mil was part of the spec the whole time, there were 5 or 6 different height specs or Z height for those E1S drives, which made it hard for guys like you to say, okay, well, what do we do? Do you want us to make a system for 5 different types of potential E1S drives to go in here, times Intel times AMD, whatever, and you end up with another 90 servers, which is how you guys end up with a lot of your stuff anyway. But
right, but I think we kind of solved that problem, because what we ended up doing was, in a traditional 1U platform, I think you may have seen it. We displayed a hyper platform, on the show floor, where in a traditional sense we have like 12 U.2 drives, and 6 of them on CPU 1, 6 of them on CPU 2, yep. Very balanced architecture. But we have actually designed the backplane in a way where we made it modular. So because we have enough PCIe lanes, we are able to bring the PCIe connectivity there. And one of the modules, you can take it out, which typically hosts like 4 U.2 drives, and replace with another bay, which has 8 of the, even S drives. So we have to play with what we have. I mean, we can't wait for the entire industry standards to, let's say, finalize, and, it will never converge. But I think given the fact that there is going to be a significant demand for customers for both the U.2 and even S, we are trying to figure out ways to accommodate both of them in our systems.
Well, I mean, modularity is one way to get there pretty easily, because it's a heck of a lot easier to design a little cage to hold the with a little PCB on it or whatever to connect into your existing servers, and then you don't have to do it's not a real heavy lift. We didn't talk about it, and I haven't seen a lot of support behind it, although there's some E3. I mean, are you looking at? I mean, obviously you guys are looking at it, but do you see much momentum there or anything interesting?
There is some interest, and few things we look at it, right? Like, one is we look at the processor architecture and what kind of PCIe connectivity that they are able to provide. And we are looking at a platform design point of view, how we accommodate certain type of drives and the interconnect, and how do we make sure that it has some level of backward compatibility. So that is, one part of it. And the other aspect of it is we work with all the drive vendors to see what they are having it in their pipeline, and whether it's going to be 6 months out, or 9 months out, or 12 months out in their roadmap. And we take that and we talk to our customers to see, what exactly the problem that we are trying to solve, and is it actually a problem for the customers? I mean, or is it just that we are creating a problem and solving it? So these are the approaches that we are taking in looking at the things. So of course, E3 is something that we are looking and talking to customers, and in some shape and form, the platforms will come out with support for it when it's needed.
Yeah, I mean, where's the gravity, right? You can't just follow every new standard until there's some sort of density there and customer demand to go do it. Things like the OCP mezzanine card I mean, that was generation 3 really before a lot of server vendors took notice and started including that. And now almost every server we see has at least one of those little guys in the back.
Yeah,
so it can take some time, sure.
I mean, you've been, watching Supermicro for some time, and I've been in Supermicro for 13 years. And I think the first one that we have done is something called a UIO, or a universal IO, where we literally cut out a part of the motherboard where you can put this card. That way, one do not have to invest in, like, again, 20 different platforms. We can have, everything connected. Then, from UIO, we changed to WIO with a similar support. But then it's a logical transition for us to adopt industry standards. That's why the OCP 3.0 mezzanine card support came into our platforms. And as you can see, even that standard is continuing to evolve as the next generation NDR connectivity that we need to bring in. All of a sudden, the standard half height kind of a card is not going to be sufficient because the connector itself is big enough. So now we are talking about evolving standards, and we are trying to figure out how to accommodate in our platforms.
Yeah, I don't envy the position because, just in this conversation of about an hour, we've talked about, 8 to 12 new technologies that are coming down the road that the students, the educators, the researchers that are all at these HPC conferences are excited about. But these workloads are becoming more mainstream in the enterprise. I mean, if you're a big organization and you don't have, an AI ML initiative, I just don't know how you survive anymore. I mean, we here in Cincinnati are surrounded by, Kroger and Macy's and GE Aviation. I mean, those guys they're embracing it because they have no choice. And these problems aren't going to get easier over time because smart people are going to ask more complicated questions. And once we understand what the data can give us, then we're going to ask more and more and more. And the technology's got to be there. And so, again, I mean, we've talked about it a couple times, but all of these things like weather modeling and these really intensive applications that are going on at Human Genome, at supercompute, this stuff will eventually become part of an organization that may not be modeling weather, but wants to model a loss prevention or shelf restocking or self-checkout or whatever else is sort of trendy in their market segments, and that is happening. And if you're not doing it, then you're almost certainly being left behind.
I mean, I couldn't have said it any better because you mentioned few names even in Cincinnati. Then the people talking about the inferencing at the edge in the retail segment. I mean, as we have self-checkout, and how do we minimize the fraud detection in that, right? I mean, it's a very simple thing. And how do you develop those training models that actually happens in a data center? If you're talking about medical research, depending again on what kind of things that you're doing. I mean, the HPC at the edge and our, AI and ML happening at the edge is a lot more. And I think we are just barely scratching the surface. I mean, there's a lot more to be done on that front. And within a data center,
yeah. Well,
and anyways, I think I can go on and on. It's just too much. Yeah.
I didn't even really want to start to go down that road because there is so much. But what we had talked about with the advent of 5G, like that was one of the linchpins for AI at the edge to really become a thing, right? So, when you guys, Supermicro, think about 5G, it's more encompassing, right? Because I know you guys have systems that are going in the towers and helping the carriers actually manage networks. But now that those networks are up and available, that lets you do a lot more at the far edge of putting a device in smart cities, for instance, that can now have high-speed connectivity without a cable or a lot of complexity, and do traffic analysis and security analysis and police support and all sorts of other things. It's really remarkable. I don't want to get into it because we're going to spend another hour on that topic on this pod. But this is awesome. I was glad to see you last week. Supermicro stepped up in a big way. I think that of all the people I talked to at the event, attendees, exhibitors, that there was there were a lot of swagger there with what you guys were doing, and it was awesome to see and awesome to be in person. And I'm off to reInvent next week, so I'm thrilled to keep going and seeing what else is going on out in the world. But I'm glad you guys did that, and I hope to see you soon. Thanks for doing the podcast. I appreciate it.
Thank you for having me, and finally get to see you without the face mask on. Now that we are back in our offices.
Very good.
All right.
Thanks.